base 3 of 3x is equal to log base 3 of x plus log base 3 of 4 minus x. And you're asked to solve for x. So we are solving for x. Okay, what we have to do is on the right hand side we have to combine the terms. So left side you have log base 3 of 3x, and then right hand side, because it's a plus in logarithms, it means multiplication. So log base 3 of x times 4 minus x. Since that's log base 3 and that's log base 3, then 3x has to equal to x times 4 minus x. So simplify this before we solve. So we're going to have a 3x is equal to 4x minus x squared. Let's take everything to the left. So when I do that, I'm going to get x squared minus x is equal to 0. Then we're going to factor. We're going to have, and then we're going to set each factor equal to 0. So x is equal to 0, and then x is equal to 1. So those are two solutions. It doesn't necessarily mean that we can use both of them. So we're going to put in 0 right there, check and see if it works. And I cannot take a logarithm of 0, so I have to toss that out. I'm going to put in 1. So 3 times 1 is 3. I can take a logarithm of that. Put 1 right there, and that works. I can take a logarithm of 1. And when I put 1 right there, I get a 3. I can take a logarithm of 3. So I only have one solution, and that is x is equal to 1. Alright, so let's do the next one I want to do is 122. So 122, we're also solving for x. So solve for x, and then you're given square root of 128x is equal to 32 times 64 to the x. Alright, if you notice that I could write 64 as 2 to a power. Okay, well, 2 to what power is 64? Well, let's figure that out. I can write 128 as 2 to some power too. So when you raise 2 to the third power, I know that's 8, so that means 2 to the fourth is 16, 2 to the fifth is 32, so 2 to the sixth is 64, and 2 to the seventh is 128. Okay, so I can write this as 2 to the seventh, so I have a square root of 2 to the seventh raised to the x is equal to, of course, 32 is same thing as 2 to the fifth. Then I have 64 is same thing as 2 to the sixth. That's raised to x. Let's clean this up some more. I want to get 2 to the 7x raised to the 1/2 power, because that's what the radical means. And then I have a 2 to the fifth times 2 to the 6x. Power to power, we're going to multiply. Of course, when we multiply, we're going to have to add these. So I have a 2 to the 5 plus 6x on the right side. The left side, when I raise a power to a power, I'm going to multiply those. So I'm going to get 2 to the 7x over 2. Since the bases match up, my 7x over 2 has to equal to 5 plus 6x. Multiply everything out. 7x is equal to 10 plus 12x. Okay, take 7 to the right, take 10 to the left, and we'll get a negative 10 is equal to 5x. My x is equal to negative 2. Alright. Next one is 125. So number 125, let's solve for x also. We're solving for x. So we have 5 to the x plus 1 is equal to 25. I can write 25 as 5 to the second. Since the bases match up, my x plus 1 has to equal to 2. Okay, my x is equal to 1. Done. Okay, there's typo on 130 and 132. So I'm going to go ahead and do 130 and 132 for you. So 130, it should be 3 2 log base 3 of 5. That's what it should be. It says base 10 right now. Right, first things first, I'm going to take the 2, put it right there on the top because of power rule. So 3 to the log base 3 of 5 to the second. When that base and that base match up, they undo each other. You're going to get 5 to the second, and 5 to the second is 25. Right, last one. So 132, you have 2 log base 2 of 9 minus log base 2 of 3. Well, this 2 goes up on the top, and that becomes log base 2 of 81 minus log base 2 of 3. So this is log base 2 of 81 divided by 3 because subtraction means division. Divide, excuse me, log base 2 of 27.